Hello, good afternoon. So today we're talking about split brain patients. The general theme we have is, this is a split brain, the distinction between thinking of other people as targets of your imaginative understanding, trying to get inside the mind of someone else, as opposed to having a scientific explanation of them. It's really natural and a really hopeful idea that these are maybe just the same kind of thing, maybe getting an imaginative understanding of someone else, understanding how the world seems to them. Maybe that's just a kind of crude way of getting at what the same thing as a scientific explanation gets at. You're just trying to find what makes this person go, after all, what drives them, what makes things happen with them. When you're getting an imaginative understanding, and isn't science doing the same kind of thing? So the contrast is between imaginative understanding and scientific explanation. And then you think, well, what do these have to do with one another? And Nagel's point in this article that we'll look at today, Brain Bisection and the Unity of Consciousness, is that when you look at patients, so-called split brain patients, you see a way in which imaginative understanding really comes apart from scientific explanation. Incidentally, please keep tabs on the syllabus, on the readings for each lecture as we go along. We're completely reorganizing the class this semester, and on Monday we're going to be looking at Jackson's article, Epiphenomenal Qualia, in the Chalmers collection. As with most of these articles, it's relatively brief, 8 pages, but it needs a fair amount of reading. And let me just check, actually, B-space, we had some glitches with B-space, but I hope that I sent around some links this morning. If you've tested them out, have you been able to get onto everything that you need to? No one's... Put your hand up if you've had any problems. Yeah? Oh, the B courses thing does work. I see. The B courses thing I did experimentally, but it's working, and Rolled Reliable B-space isn't working.
Well, no. B-space didn't let me do it at all. B courses for all my other classes work,
but not for mine. Okay. Well, the links I sent round this morning should let you get onto all the course information directly. It's on my own website, yeah. So you don't even need to go via B-space or B courses. You can just get onto it directly, yeah.
the links that you sent worked.
The links I sent did work for you?
The email, yeah.
Yeah, okay, good, right. No one's had trouble with the links I sent on email? Okay, well, check your email then if you've had trouble getting the course information. I think those links should get you through without any trouble. Okay, so let's look at brain bisection and what importance it has. The general point here is, when you reflect on what your own mind does, what it means to you having a mind, well, basically, you're in charge. You're a single authority in charge of what your body does. Sometimes your body might let you down. Sometimes your body might not do what you want it to do. But you are the fundamental decision maker for everything that happens. There's a single unity in charge of everything that you do. And when you get an imaginative understanding of someone else, what you're trying to do is, how should I say, access the CEO or the dictator or the thing in charge of this whole physical organism. That's part of the point of trying to get an imaginative understanding of other people. The mind is where all the decisions are made. But, so, getting inside someone else's head seems to require that you get at the center from which all the commands are being issued. But when scientists look at the brain, what you find doesn't seem to have that kind of structure. You don't find something that looks like a dictatorship with a single bit of the brain in charge of everything else. What you find looks more like the European Union than it looks like Romania in the old days. The brain doesn't look like a single dictatorship. It looks like a kind of federation of semi-autonomous regions, all wired up to one another, all kind of jostling for position. And you don't see that unified center of consciousness anywhere in the brain. So when you look at what's ultimately going on in the brain, you don't get something that lets you generate the kind of imaginative understanding of a unity that we usually take ourselves to have. Now, in brain bisection cases, the idea of a unified consciousness really falls apart pretty dramatically. So let's just look at what's going on here. The basic idea is there are two hemispheres in your cerebral cortex. There are two halves to your cerebral cortex at the top of your brain. The left hemisphere is thought to control speech production. So what's going on at the left top is controlling speech. That's what gets your speech out. The left hemisphere is also taking information from the right of your visual field. So the stuff that's coming in on the right of your visual field is going to the left of your cerebral cortex, and then the left of your cerebral cortex is in charge of the right of your body. So, follow me very closely here. It comes in from the right, goes up to the top left, and then the action being controlled is on the right again. Yeah? And if you ask, how does it go with the right hemisphere? Well, what do you think? If it comes in from the right, it goes up to the left and then controls movement. Sorry, what did I say? If it comes in from the left, goes up to the right hemisphere, and then the right hemisphere controls what happens in the left of the body. Yep. Plain as day. Now the corpus callosum is a large band of transversely running nerve fibers that connects the two hemispheres. It's kind of a communication system between these two hemispheres. So if, as I stand here, a guillotine blade were to come down from the ceiling and cut me neatly in two for demonstration purposes, right? So suppose that this side of my body just fell off and you could get a good look at the brain, then something like that is what you'd see. And the corpus callosum is that thick bit indicated there, running right through the brain between left and right. Okay? And here's Gazzaniga, one of the pioneers of this kind of work, making a conjecture as to what's going on, why this corpus callosum here is important. In most animals with brains like ours, in most primates with brains like ours, what goes on in the left and what goes on in the right is pretty similar. You get perceptual processing in the left, you get perceptual processing in the right. You don't get language, obviously, but most of the rest of what goes on is just mirrored in the two hemispheres, right? So you get a lot of redundancy. And Gazzaniga's idea is language emerged for humans in the left side of the brain. But what that meant was that the perceptual processing, the visual processing, for example, that used to be going on in the left side of the brain, now that's been taken over by language. So if the left side of the brain is going to function well, it needs access to the perceptual processing that's going on in now only in the right side of the brain. You see what I mean? So the corpus callosum is very important then, because you really need communication between the left and the right in a way that you didn't if the two hemispheres were just mirror images of one another. So it was really important to have communication there. This is kind of what I mean by a federation. You've got a lot of individual blocks here doing lots of specialized processing, but it's really important that there be good communication between them so that you get organized activity. So you get an efficiently running federation. You have no one thing in charge. You just have very good communication. By having the callosum serve as this great communication link between redundant systems, you see what he means? Redundant in that one's just doing the same as the other. You could knock either one out and the other one would keep going. So you start off with redundant systems. You've got a spare, as it were, for everything you do, two systems doing it. Then you get very good communications. And that means a pre-existing system can be jettisoned. You can throw away the bit here that used to be doing perceptual processing and say, let's use that for language instead. The other hemisphere can continue to perform the previous functions for both half brains. Okay, so that's Gazzaniga's conjecture as to what is going on with the corpus callosum, why we have that. It was thought to be, for a long time, to be absolutely baffling what its function was, this thing. The reason was, in cases of epilepsy, when people are having epileptic fits, do you know what I mean, epileptic fit? It is really a scary phenomenon if you've ever seen this at close quarters. Yes, someone is just out of control. You don't want this to happen. And what goes on there is that you have a kind of storm of electrical activity, a firestorm of electrical activity in one bit of the brain that then spreads to the rest by way of the corpus callosum. So just to cut down on epileptic fits, they tried cutting the corpus callosum. Let's not have that communication system anymore. And people work just fine when that happens. It's a very good therapy, right? You don't get the epileptic fits anymore because you are containing it the way you contain a forest fire. You're putting a boundary on how far this electrical firestorm can spread. And there didn't seem to be any behavioral defects in these people. So here's a picture of what's going on. This is the brain from the top. So you see there's a left field going to the left. The left field going to the right hemisphere, then controlling movement in the left. The right field going to the left hemisphere and controlling speech and movement in the right. And the corpus callosum in between them. And then you just cut that. And people still function perfectly well. Yep. Here it is in color. Do I need to? That I guess is redundant too. That is basically the same picture. So you've got an apple in your right visual field. Notice, incidentally, it's visual field, not eye here. Both your eyes are contributing to the left visual field. Both your eyes are contributing to the right visual field. But if you've got an apple in the right visual field, it's the left hemisphere that's processing it. If you've got a pencil in the left visual field, it's the right hemisphere that's processing it. Yep? And communication between the two being served by the corpus callosum. And as I said, when that's cut, no significant behavioral or mental effects in these patients could be observed. There was one patient who was very fond of making model cars, right? Very fine-grained work, this, right? If you're going to make that kind of race car out of old beer tins, you need good coordination, right? You need both hands working together in a very fine way. People can play tennis just fine after this. Yeah, tennis, you need pretty good whole body coordination, left and right working as a unity. People are just fine in these ways. So these patients, you could put that by saying they're fully functionally integrated. They're just as organized as anybody else. They are not dysfunctional in everyday life. If you look at the video I linked to, it starts out really touchingly with one patient saying, well, if I feel just the same as before. It feels no different to me. I do my life just as before. It's just like, now I know I got a backup brain, but it doesn't really make any difference to my experience in everyday life. That's what he says. The subtle, interesting things about these patients came up when experimenters started using tachistoscopic presentations. Can you say Can I say tachistoscopic? Tachistoscopic meaning very brief presentations, just a few hundred milliseconds. The thing is, if you think back to this scenario with the bit in the middle being cut, well, usually it doesn't matter, because if you think of it, even as you sit here now in a pretty static situation, your head and eyes move the whole time. What was in your left visual field just a moment ago is now in your right visual field. That's really easy. Look, you can try this, right? It happens really quick, really fast. So you can make sure, in effect, that each hemisphere is getting complete information about the scene just by moving your head, right? Or just by moving your eyes, in fact. Yeah, happens really fast. So you get, as it were, external communication. There are those external ways of making sure that the two hemispheres are both getting full information. But when you've got a tachistoscopic presentation, when something is flashed up just very briefly, just for a few hundred milliseconds, that's too fast for you to do that thing of moving your head or moving your eye. You're only getting just a static moment of the display. It might be quite long enough for you to see what's in the display, but it's too fast for you to make sure that both hemispheres are getting all the information. So the kind of scenario was, in the left field, the patient's told, pick up a pencil. So in the left, you're being told, pick up a pencil. And the right, on the right of your visual field, you're getting the instruction, pick up the toothbrush among a tray of items there. So if that's what happens, you're told, pick up the pencil in the left field, and you've got no communication between left and right hemispheres. Well, what's going to happen? What your information is your right hemisphere going to get? Sorry? Pick up the pencil, right? Yes?
Is this for patients with split brain?
Yes, right. Yeah, so you don't have that rapid communication between the hemispheres, right? Okay, so the right hemisphere has now been isolated from the left hemisphere. You're making sure that they don't have the same information. They're not getting in this external way by you moving your head, and they can't get it by the internal communications because that's been cut. Yeah? So the right hemisphere is only getting what's in the left, not what was in the right. And the left hemisphere is only getting what was in the right, not what was in the left. Did I keep right? Can you keep me straight and right and left? You see what I mean? Okay. So if that happens, then the right hemisphere is getting, look for the pencil. So it's in charge of your left hand. So your left hand is going to be looking for the pencil. Your left hemisphere is getting the instruction in the right. Look for the toothbrush. So it's in charge of your right hand. So your right hand is going to be looking for the toothbrush. Yep.
So with this person, when this is happening, would they have any other idea that the other half of their body is searching for different objects, or to them only one hand is searching for something?
Well, they can see what's happening, right? They can do this and say, wow, look at my hands, right? that raises some curious issues, right? Which I'll come on to in a second. I will say, one patient in that situation said, looking at what his hands was doing, said, "Is these tablets I'm taking for you've made me take? I'm kind of high." That seems to be a perfectly rational reaction. If you found your hands doing that, that is what you'd say. What was in those tablets you gave me? Yeah. But there are actually lots of interesting things happen on just that point. So, look, here's someone in this kind of situation there's a tray of objects there, and this is their instruction, what they are to look for. And that's being flashed up really fast. Yeah. So, he's got key on the left and ring on the right. So the left hemisphere is getting ring, the right hemisphere is getting key, and therefore what's happening? The left hand is picking up the key, yeah. The right hand is picking up the ring, and if you ask him, what are you looking for? Well, which hemisphere does the language production? Right, so the left hemisphere got ring, so he says ring. I'm looking for the ring. And if you ask him, how come you picked up the key? He really has a problem because the speech production only knows about the ring instruction, doesn't know anything about the key instruction. So he has a problem as to what he's going to say to that question. That was your point. Yeah. But notice too, these two halves there make up, there's a kind of behavioral disorganization here, dissociation, right? Disorganization is a bit too strong because each component is individually perfectly well organized. It's just that they're coming apart in what they're doing. But also, he is getting a whole word there. There's a single word there, right? Keyring. So you might think if that's what you saw, you should be looking. If you or I were given that, you'd think keyring, right? But he's not getting keyring either. Yeah. So it's not just that his movements are disorganized. There's a dissociation in what he's representing. Philosopher Tim Bain, who's written quite a lot about this, says you've got behavioral and representational disunities. And it's a real hard question. What is he seeing when he's looking at that? What is his visual experience? What? Yeah, but there's only one person there. What is the visual experience of that person? I'll come back to this. Yeah. So look, here's another case of that again goes over the same kind of point. This is someone who, as you can see, is traditional in these experiments to remove the top of the patient's head so you can get a good look at what's going on. So you can see there what's happening in his brain, right, in the left and right. So he's being shown a snow scene on the left and a chicken's foot, a chicken's claw on the right. And then there's what is that, 8 pictures below. And what he's asked is, point to the picture in the row of 8 that goes with the scene that you're seeing. That's his task. Yep. So with his left hemisphere, he's getting the chicken claw. So his right hand is pointing to the chicken head. Yep. With his right hemisphere, he's getting the snow scene. So his left hand is pointing to the shovel. Right? Yeah. And now, what the questioner asked earlier, what's he going to make of this? He says, someone says to him cruelly, why are you pointing to the shovel? You see why that gives him a problem? Because his left hemisphere has to do the talking. And his left hemisphere doesn't know anything about the snow scene. Yeah? You see what I mean? You see the problem? And here's what he said. When asked why the chicken, he said it goes with the chicken claw. When asked why the shovel, he responded, to clean up the chicken coop. Good thinking. And that's what people do, right? That's what we all do the whole time. We tell stories that make sense of our actions, right? One of the earliest things very young children learn to do with language is to say things like, well, I meant to do that, or I wanted that to happen. You see what I mean? You just tell stories that make sense of your behavior. So here he is with the head cut off and top of the head cut off, and everything coloured in by dyes, and saying, well, you need the shovel to clean up the chicken coop. So the concealed object is placed in the left hand, and the patient is asked to guess what's in it. Well, the left hemisphere is not getting it. The language production hemisphere is not getting it. If the left hemisphere makes a wrong guess, the right hemisphere hears what this guy is saying. So he says, if he gets a pipe in his left hand, and he's asked, well, what's that? And he says, it's a pencil. The right hemisphere, which knows there is a pipe, hears that and says, no. Right? But if the speaking hemisphere guesses correctly, the result is a smile. Yeah? Okay. So that's the basic phenomenon. Brain bisection. Yeah. As I say, the videos are wonderful. It occurred to me, it seems kind of slack for a lecturer just to play a class of video, so I didn't do it. But maybe I should. You should just see. You get a sense of it much better when you see people discussing the condition. Yeah. Yes. Yeah.
I have a question. So about the shovel thing.
Yeah.
Does that mean that person does not, his consciousness does not respond to what's showing on the left side of the screen? Does that mean?
His consciousness does not respond to what's showing on the left side of the screen. Well, what's showing on the left side of the screen is the snow scene. Yeah? And my guess would be that's why he picked up the shovel. So he's responding to it in his actions. Sorry?
What's the, so is that he can't, well, his brain doesn't just incorporate why he picked a shovel for the snow scene? I don't really get it.
Well, in his use of language, he's unable to say why he picked up the shovel. Yeah? Nonetheless, I mean, he's unable to give the correct answer as to why he picked up the shovel. Nonetheless, it may well be that he's conscious of the shovel. It's just that aspect of him that's conscious is not able to say why he did that. Yeah, that's very on what is so strange about this case. Yeah, how can you be conscious of it but not able to say? Yeah. Yep. Yep. Sorry, did you give a question? Yes.
She asked part of it.
Okay. Sorry. Okay, 1 and 2. Yeah. Right.
How does this not bring up broader issues in everyday life if you see something on the left, or only on the left, and then can't communicate, just walking around?
Yeah, shouldn't that come up in everyday life? Well, I guess it usually doesn't, just because of that thing I said that our heads and eyes are moving the whole time. Yeah, and it's really only under these very controlled conditions that you get something showing up. I mean, if something just showed up for a couple of 100 milliseconds in your left, you really might get some effect where your right hand responds and your speech comes in only a bit later. Yeah, but partly I think there's a lot of confabulation that we do ordinarily. I mean, there are classic cases like you put your hand in a radiator, yeah? You take your hand away immediately when it's very hot, and you say, wow, that hurt. That's why I took my hand away. Now, when you measure people doing that kind of thing, what you find is that the reaction of jerking the hand away happened far too fast for signals to have gone up to the brain and then back down to generate the movement. The movement was a reflex that just came at a much lower level than being centrally controlled because of pain. You see what I mean? You can just show that. But nobody ever bats an eyelid about that. People say, well, I pulled my hand away because it hurt. Yeah? Nobody says, "Wow, why did I pull my hand away?" You just, I mean, we are. That's what I meant. That actually, that we are all much more like this patient than we might like to think. We tell ourselves these stories about why what we are doing is perfectly sensible the whole time. So even if it did turn out that there's quite a lot of what you mentioned going on, we would, I think, just confabulate in this kind of way and not even notice. Yeah. Yes, yes. I'm sorry. That's not deliberate. I don't know why. Yeah, please.
I just want to ask about the key and ring thing. So
Yes, the keyring. Yeah.
The patient responds with ring, but does he actually know that he holds a key?
Does he actually know that he has a key? Yeah, that's a good question, isn't it? What's knowledge? I mean that seriously, actually. Does knowledge mean you have to be able to say? Yeah, I think it puts a lot of pressure on what we mean by knowledge, that issue. I mean, if you're doing an exam, yeah, then it doesn't really cut any ice to say, "Oh, well, I knew all the answers perfectly well. I just couldn't tell you any of them." Yeah, in an exam context, know just means you can say, yeah. Or if you ask me what time is it, or what's your date of birth, and I say, "Oh, I know it perfectly well. I just can't tell you because of some rare brain deficit." And it doesn't. It hardly makes sense, yeah. But on the other hand, there are cases where it seems like we do talk about what you know, you knowing something even though you couldn't say it. I must have known that there was somebody behind the door. That was why I didn't go out. You see what I mean? Something tipped me off that a burglar was hiding. I don't mean to sound too nervous here. But something tipped me off that there was a person behind that door, even though I couldn't have said. You see what I mean? Sometimes our behavior seems to be controlled by stuff that we couldn't have literally stated.
I think both hemispheres
Can think?
Yeah, and only the left controls
Yeah.
language, so it's weird. I think the patient does know that he holds both the key and ring. He can
Yeah.
only express ring.
There's some sense, I think you're certainly right, that there must be some sense in which the patient knows that he's looking for a key. He has to look for a key. He knows that. Otherwise, why would he reach for the key? Yeah? He must know that the word key is there, even though he can't say. Yeah? So that's actually a perfect case of the kind of knowledge I was describing. Yeah. But your questions really put a lot of pressure on what we mean by knowledge or what we mean by thinking. And yeah, so it just needs some talking through. You're behind you? Did you still have a question? Yes. Okay. Yes? Yes, sorry, you. Lady in the blue, yeah. I'm sorry, I thought you put up your hand, but perhaps you didn't. Okay. Yes, you. Yes. There must be something going wrong with my pointing. Let me.
If we turn the key to the right and
Yeah.
ask, what did you,
If you move the key to the right, yep.
what did he just know? Can he ask, can he enter the key?
He won't be able accurately to answer the key. Yeah, because it really, if you did this fast enough, yeah, in a controlled enough way, he might be able to get to say, well, he might be able to figure out, oh, it must have been a key. It must have been the key. That must have been what I was looking at. Yeah? Is that what you mean? Yeah, that would likely give him enough to figure out. That was what that must have been the word I was looking at, since that's what I picked up. Yeah. Okay. Yeah. But why would that be? If you just think about typing, your eyes are moving like this. Yeah? So it's going from the left of your visual field to the right, just the whole time as you're typing. You see what I mean? It's a very unusual situation to have somebody frozen for just a few hundred milliseconds staring at a fixation point here. Yeah, that's... Yeah. That and the confabulation. You might say, God, my typing's just not as good as it used to be. You see what I mean? But without necessarily focusing on anything. Yeah. Okay, quickly, and then then we should move on. Yeah.
If they closed one eye then and were typing, would then they have difficulty?
No, because remember that it's not which eye, it's which half of the visual field, and both eyes get both halves of the visual field. Yeah. Yeah.
I just also remember reading that both sides control the neck. So if like one feels that there's something to look at, they're able to like move the neck really fast.
Yes, very good. Yes.
In everyday
Yeah.
life, it's
Yeah.
like not really an issue because like both sides control the neck. They can both see what they want to look at.
Very good. I'd forgotten that, but that's certainly true. Yeah. Yeah. Okay, good. Now, the key point here is that we're talking about imagination in scientific explanation. And I hope it's clear there's a kind of gee whiz when you think about these patients. And the point is, you have no idea, you can't imagine what that experience is like. You can't put yourself into their shoes. You can't understand imaginatively what it's like from their point of view. The intriguing thing about them is that getting a scientific or functional explanation here of the kind I just gave is really almost childishly simple. I mean, you can objectively understand exactly what's going on. It's a little bit tricky keeping left and right straight, when you're working through it. But that's about as hard as it is, really. Yeah. Getting a scientific understanding here is not, in principle, all that difficult of how they're wired up and how they're going to behave. But then you ask yourself, so the scientific explanation is not, in principle, all that complex. Of course, there's endless complexity in the details, but the kind of thing we're getting here is not all that complicated scientifically. But then you ask, what's my imaginative understanding of who's in charge? The subjective life, the conscious life that is making this patient do what they do. Well, you don't have that at all. You don't get any imaginative understanding of the CEO of the whole operation when you try and put yourself into this patient's shoes. Because what are you to imagine? What do you make of it when the patient looks at the screen? How do you imagine what the patient is seeing? Do you imagine just one half? Do you imagine the other half? Do you imagine them both? None of these is right. There isn't a way of getting an imaginative understanding of what the patient is seeing. You can't do it by imagining just one of these aspects, because, after all, the other part is playing a role in generating the patient's movements. You can't do it by getting both, because that's just what the patient doesn't have, a single unified conscious experience of both sides. There is no way you can get an imaginative understanding of what the patient is doing. So this is a very simple case, really, in which, on the one hand, it's pretty easy to get a good understanding of what's going on scientifically with the patient, but it seems thought-stoppingly impossible to get an imaginative understanding of what's going on here. Sperry himself said, instead of the normally unified single stream of consciousness, these patients behave in many ways as if they have two independent streams of conscious awareness, one in each hemisphere. And when this work first came out, there is a philosopher, Roland Puccetti, who my memory is, Puccetti said, actually, what this shows is that there are two different people in the split brain patient. And actually, when you think about it, each of us is two different people. You and I right now have two different people inhabiting the same body. It's just that they get on pretty well and they have a good communication because of the corpus callosum. This view has not survived the test of time. This is a crazy view, right? That can't be right, that there are two different people inhabiting your body. Whatever science has shown here, it's not that. There are two different people inhabiting the same body. But the great thing about Puccetti's view is that it was clear. If you don't say that, it's very difficult to know what to say here. And we don't want to say we're dealing with two different people just because of the thing that you guys have been raising. Their behavior is just as integrated in ordinary life as yours or mine. And it doesn't seem right to say only the right hemisphere has got the consciousness, because after all, it's the left hemisphere that's doing the talking and saying what they experience. But if you said, well, actually, only the left hemisphere has got the consciousness, the fact is the right hemisphere does lots of things like face recognition or emotional processing that you usually think is just essentially part of your conscious life. When you look around you, you're identifying faces, you're having emotional reactions to them. And that seems just deep in your conscious experience. So there's no problem about giving a functional description of these patients, how they're wired, what they'll do. That's what we just worked through. But what you can't get is a picture of what experience is like for them. Just one other thing here. There's this, in one of the videos, there are these Arcamboldo paintings, some of you might have seen them, of vegetables that are arranged to form faces. Yeah? And it's thought that the right hemisphere does face processing, or maybe global processing of a scene. The left hemisphere does more detailed processing of the scene. The left hemisphere does the trees, if you see what I mean, and the right hemisphere does the wood. And if you show a patient, this split brain patient, this Arcamboldo picture, and say, okay, what are you looking at? Point to the word that describes what you're looking at. Well, the right hemisphere is getting the face. The left hemisphere is getting the vegetables. So the left hand points to the word face. The right hand points to the word fruit. Right? Okay. Let me just show you. You can, if you have two pens and a bit of paper, you can try this right now. Let me just show you one advantage to being a split brain patient. Suppose you're asked to copy those two diagrams. Right? Copy the one in the left and copy the one in the right. Yeah, you could do that. Either of them is easy. Yeah, I mean, don't do that. That's surely you guys can do a triangle or a cross like that, right? That's not hard. I mean, look, I can do it. There you go, triangle. Well, it's not that great, but you see what I mean, right? That was okay. Right. Okay, but now, okay, if you've got your thing, you can do this right now. Copy them both simultaneously. Copy the triangle and the cross. Okay. God. Well, actually, that's not bad. That's the best I've ever done. Right. Okay. I guess I'm getting practice in this. The thing is that regular people have a lot of trouble with this, right? Split brain. Did any of you try this right now? Yeah. How did you do?
Like, I had to slow down and finish the triangle before I finished the cross.
Oh, right. Okay. Okay, the thing is, split brain patients can do this without any trouble at all. Split brain patients, look, here are some. Here's on the top top right and the top left, you've got a regular person copying two things that are mirror images of one another. So that's dead easy, right? You can do that. If it's the same shape or the two mirror images, you can do that. But if they're different shapes, as in the thing I just did, regular people do really badly, right? So you can see that person at the bottom left is not doing too good. There is a split brain patient copying the same pair of things, yeah. Split brain patients do it just fine. So there are advantages to being a split brain patient. Yeah?
Like how could they like do homework with one hand?
Sorry?
Like how good is their ability to do this? They do homework with one hand and homework.
That's right, they do it just fine. I mean, they do it just as well as you or I could copy each figure separately. Yeah, that's what that is telling you, yeah.
So we could do like homework, or they could do like different homeworks.
Isn't that interesting? Yeah, this is only about drawing shapes. Yeah, but yeah, but no, it is a very interesting question about splitting attention here. I once read a science fiction story that began with an alien sitting on a sofa reading two books simultaneously, and I love that because there's something subtle about it, but it's really mind-bending at the same time. Anyone who can read two books simultaneously, I mean really simultaneously, not switching from one to the other, but reading them simultaneously, that's just someone who's very different from an ordinary human. Yeah? There's something deeply true about the idea that you can only attend to one thing at a time. And it doesn't seem to be true of split brain patients. It does not seem to be true that they are like this alien, that they can really split attention like that. But it's one of the interesting questions that's raised. Okay, so just to say again what the basic theoretical point is here. It couldn't be right, because of these kind of points, to say that knowing someone else's mind is just knowing some kind of scientific or proto-scientific theory about them. It's a very natural picture of knowing other people's minds, but it can't be the whole story. Because if you've got a purely scientific account of the federation, the loose federation of different units that comprise the European Union, as it were, of the brain, that can't explain where it comes from, this idea that there's a unity to the mind, that there's just one center of consciousness here, and that when you imagine someone else's position, what you're doing is getting to that center of consciousness. And of course, this isn't a mark to say, I mean, people often take this kind of point and say, so that shows there's a soul, or that shows there's something non-physical here. But I hope it's clear already that that would completely miss the point. It's not at all that there's some other kind of stuff here. Because what would that mean, there's some other kind of stuff here where it's really got a center? What are you talking about? What we're finding out is that in the only stuff that's there, the physical stuff, there isn't a single center of consciousness. So however you think about what's going on in imagination, it can't be just giving a description of what's going on with any objectively there stuff at all. Okay, we'll look at Jackson's article on epiphenomenal qualia on Monday. Okay, thanks guys, great questions.